Hello everyone, my name is Tương, and today I'm gonna talk about our team solution to the TriMa Institute Problematic Index Use competition. So let's talk about the data we received in this competition first. So the data consists of category files. So what are saved in Parquet saved in Parquet with ID, and then we have a CSV file called train or test.csv contain this field. We can see in the uh, data dictionary here. Okay, let's talk about those fields. Okay, so let's talk about the CSV field first. Mm, the CSV field, the CSV data is collected with the participant go to the research, then they will give some physical measures and some fitness measure here, and then the parent of the participant will answer some 20 questions, namely here, and they will be scored 0 to 5, and then the score is total even here, and then so when the score is total, based on this value, it can be converted into 0, 1, 2, and 3. So that is our SSI, which is the goal of this competition. We will predict the SSI based on the data of this competition. Okay, and then let's note that the test dataset doesn't only contain this part, and of course doesn't contain this part. So we cannot infer it right away. So what we gonna do here? Let's see. So in actigraphy field, let's talk about the data in the actigraphy field. This is one of the actigraphy field I loaded into Power Query for us to easily visualize. First we got steps, which is basically index and x, y, and z acceleration. Calculate the unit is g. 1g is 9.8 meter per second square. That same unit as the acceleration of the gravity. So basically, if something is subjected to 1g of acceleration, it means it is subjected to 9.8 meter per second square of acceleration. That's clear. Okay, we only actually need to care. So we can see x, y, z here, which is the acceleration in the direction, in those direction, in 3D direction. So and this value are calculated into nmo. Nmo is the basically the sum of these three values. Nmo or the nmo the unit nmo is also g. Okay, so here we have non-wear flags with 1 meaning doesn't wear, and then 0 mean they are wearing it. So we can just straight up get rid of all the variable of non-wear flag with 1 value, and then the time of day, which when I convert into this, every 5 seconds the device, namely the AG device, where in the grid of the participant will record an nmo value here. So and then the relative date. What is the relative date? This the date, the different date from the data taken in the CSV and the data taken from the actigraphy. Okay, so let's continue. And then we can take a look at the training the CSV data here. So the first group is the demo. Just there's age and sex of the participant. There's a CGAS score. What is the CGAS score? Let's take a look. This means the Children Global Assessment Scale. Is a number scale used by mental health clinicians to rate the general functioning of youth under the age of 18. Okay, let's continue. We have the CGAS score, and then we have some physical value like BMI, which basically is the value computed from height and weight. Like weight, some values of fitness endurance. So this is like corrupt, grip strength, and so on. We also have some bioelectric calculation measurement. We have and then we have the answer for some of the questions. We can see it in the data dictionary here. Okay, let's continue. So what do we do with the data? We have to process the data, and because the Parquet files are distributed all the way in the series test or train folder, so I will combine them into one. And then what do I do? Take a look here. First, I formatted the time because the time in nanosecond is really not usable. And then I convert the nmol column into milligravity. This mg means milligravity, mean 1,000 of the gravity. And then I give it and then I filter only if the non-wear flag equals 0. Continue. Because if it's equal 1, then the wearer is of course not wearing it, right? And then so when I combine, I do that, and then I give it an intensity. Why do I have to do that? Okay, let's take a look here. If the nmol is in this range, I give it a value of still. And if the nmol is between 50 and 28, it's the light. Why do I do this? Because this is the intensity of the action of which the participant is doing. Where do I get this value from? By 50 threshold from? I get it from this scientific report. This tree. Okay, let's take a look at this one first. Intensity threshold of raw acceleration data. Yeah, just the nmol here. Okay, let's take a look at nmol here. And namely, I want to take you to page 10. Okay, page 10. We are using the AG. We are using the AG device. Why do we know this? Because this competition used the AG data. This competition used the AG device to measure. Where? Okay, continue. Okay, let's take a look at this. So basically, when standing still, the nmol is 0. And yes, this is the nmol threshold here in milligravity. Same unit that I'm using. So you can see it's very small value when standing still. Even when washing pot is still basically basically a still action. Dusting also use stand still for dusting. Okay, when you sweeping floor is a light action. So I keep it here. Okay. Yeah. So that is another one is also is this one. Okay. You can see it clearly here. AG risk where some of the value for the action here. So you see running 8 km/h, which is quite intense actually. So this is the value here. This is quite intense. Another one is this one. This one is the top. Yeah, it's a top highest uh, acceleration and value for the top X minute. So M2 mean top 2 minutes of the day. So you can see in 1 day we only have like 2 minutes. The children can only do 2 minutes of this intense action. So yeah, so 15 minutes for 700 value, 750 value, which I use in my code here is reasonable. So yeah, I base this value here on those three reports. Then I gave it I gave it an intensity column, and then based on the intensity column, I will calculate the number of seconds and then convert it to minutes. So basically after that, I will have this sheet right here. Okay, so I calculate the average time for each participant or each day because there are many days. So I will calculate the average time for each day they do the action in the category. So basically for example, this participant they spend an average of 17 minutes still every day when wearing the device, and then about 15 minutes doing live action. Okay, so that is clear. The approach is clear. Let's continue. Okay, then I merge the data. Let's take a look at this. Why do I only take this column? Because my reason is other columns can be calculated from this one. For example, BMI is, you take a look at this unit and you can see it's directly related to physical height and physical weight. Same for the corrupt total and corrupt fitness zone. This this value here is directly linked to this one, so I think there's no reason to include it. And then I wouldn't include this value because this one doesn't exist in the test. This one is basically our label, so we cannot include this one. Okay, and then I have to change the name a little bit because some of the value needs scaling, so I will use so I have to change the name accordingly. This one, the name changing is not important. A little bit about the fitness endurance column because it is minute and second, so I will have to calculate it into seconds. Like if the value of minutes is 4 and the second is 3, and I can know that's 4 minutes and 3 seconds, so I have to convert it all the way back to 243 seconds. That's minute. Okay, then I merge the set. This merge is the same. Actually the merge is basically the same. Just remember this this SSI column doesn't exist in the test dataset, so I doesn't include it there. So you can see if the SSI is null, then it will be removed because that is the goal of that is the label. So I will not use the null. Even if I remove the null there, there's only 1/3 of the data which has the SSI. So, and luckily all of the package data has an SSI. Very lucky. Okay, so what I do is this impute missing value is a test. So I would test the model if I would impute value doing mode or using mode or using mean, which model will perform better. Okay, so I do it. I do all the function I didn't use earlier, and then I got the data. Then I use and let's go to the model. So I convert because this is category level. So I will convert them because when they are read in the CSV, they are 1.0, 0, 1, 1.0, 2.0. So I just convert them 1 and 2. And then, so yeah, so I preprocess the data a little bit, and then I will align GBM as the model. Let's talk about this model a little bit. So first, we have to know about decision tree. A decision tree will split the data based on the category, based on the value, right? Basically, we make a statement. If the person, for example, if the person is over the age of 20, and if they are not, they go to the other side of the tree, right? So, and then there is and then based on the decision tree, we will have a model called gradient boost, which is GB right here. And light GBM is actually light gradient boost model. Okay, I use a classifier because we are actually classifying. In hindsight, maybe I should use a regression model because the NSI is actually a continuous value, and that classify into class just because we have the converter, we have the range to convert them. But this one also work because we are class but ordinal anyway. Okay, then I save it, and then what is the result? So this is our result here. Let's see. Yeah, so this is the result. We have this score which is moderate agreement, the public score here, which is very good compared to a random guess. What did I do in the random guess? Let's take a look at the random guess code. Basically, I just randomly guess it, and the score is much better than the random guess. So yeah, thank you for listening, and I hope you find it helpful with our approach to the data. Thank you very much.